Okay, and now we're recording. Okay, so this is the Project 2 overview and introduction. I do want to encourage you guys, if you have any questions, to interrupt me and let me know, what I can make a little clearer for you. Casting a 3D printed part involves a lot of moving parts in more ways than one. So let's look at the project overview. So we're going to use Rhino, and we're going to create a ring or a wearable object. I've had people make earpieces. You could have it be a pendant. You could have it be another piece that is wearable. We generally don't want to get too large because we're casting. And so that is important. Hold on a second. Let me just real quick bring up. Yeah, okay. And so once we prepare the 3D printed model, we're going to send it to the Form 2 printers. It'll be, it'll come out, it'll have support material on it. We will clean up the support material, and then we're going to invest it and cast it during class time. Tentatively, I'm aiming for Monday, the 21st of March, which is, I think, about a week or two. It's 2 weeks after we get back from spring break. Then we'll clean and finish our rings, and we're going to have a group critique on Monday, April 11th. So here's the dates around this project. They will show again at the end of the presentation. And by the way, you do have this presentation in Canvas. So we're introducing the project today. Next week, we're going to have one-on-one meetings about your project. You should have sketches by then. Then the files are due for submission the day we get back from spring break. That is Monday, March 7th. We're going to work on post-cure and investment casting. And post-cure means that what happens is our castable resin needs some preparation before it can be used in the casting process. And what this involves is first we have to clean the support structure off of it and sand it, make the surfaces smooth, and then the 3D print tech will soak it in glycerin for a certain amount of time, and then give it extra time in the UV cure chamber of about an hour and a half. So this is not something that you guys can actually do. It has to be done by the 3D print tech, but you have to prepare your 3D print part to give it back to the 3D print tech before they will do the post-cure process. So we want to make sure that we get things post-cured and then invested before the 21st, which is when we want to cast. We'll be casting on our in-person days, which are Monday, which means that your pieces have to be invested by, I would like to say Saturday or Sunday before that Monday. Sunday, maybe at like 2 o'clock. It's really important that they sit for a few hours before the burnout process starts. Burnout, it always starts the night before we cast. The burnout process takes about 13 hours. So, and on Sundays, I'll actually be coming in to start that burnout process, but we won't be able to invest right before burnout. Your flasks have to sit for a very minimum of 2 hours. I actually recommend that they sit a day or two, which is why I like the idea of investing earlier in the week or possibly even on the Monday before. But we'll talk about specifics with each of you as you get your pieces submitted and when you get your 3D print parts back. And then as I said earlier, we're going to have our critique on Monday, April 11th. So there should be plenty of time to get things finished between that March 21st timeframe. We could possibly even cast the week after, which would be the 28th. And then we still have time to finish our parts before Monday, April 11th. Any questions about the dates? I may, add more details to our syllabus as we check in every day with the syllabus. just to make sure that we stay on schedule with this. So let's talk a little more about all the steps involved in this. It is, as I said, there are a lot of pieces to creating a 3D printed part and then having it cast. So the first thing we're going to do is we're going to design a ring in Rhino. This is a real simple ring that I designed as an example. Okay, I basically have used like sweep 2 and a, and a curve for the side and the inside, right? Then we add sprues. For those of you not familiar with the lost wax casting process, these sprues are needed for the metal to have a place to flow into your ring. The metal comes in through the sprue and then into the ring area. I realize that may sound confusing if you don't know much about this yet, but trust me. So we have to set up the sprues, and this is just a quickie kind of idea about, we have a big central sprue, we have another sprue here. We can do sprues on the inside of the ring that get cut out. There's a lot of different ways to sprue it, and it all depends on what your ring looks like, because not every ring is sprued the same way. So the next thing that we'll do is we'll go through NetFab, which is a file cleanup program that we use. It helps make the mesh more printable. We have to export our Rhino objects out to an STL file, which stands for stereolithography. And then we'll send it to NetFab. We'll fix it in NetFab. And then we'll submit that file on the server to the 3D printing folder under Form 2, under castable wax. Anytime you submit anything to the server, I must approve it. We have to send a form to the 3D print tech saying, hey, there's a file in there that needs to be printed. It's for this class and this instructor approved it. So you and I will be doing this process together. Step 4, we'll get it back. This is what it's going to look like. Okay, it's going to have all this little support structure stuff on it. And that is not necessarily, we don't want to keep that on there. We have to get that cut off, and we don't want to keep that. We're going to have a sprue on it. In this example, there is no sprue on this, but we will have a sprue. There are certain tools, special tools, that we keep in the tool room for this process. We use the plastic cutters that are meant for cutting 3D prints or plastic. We don't use our metal tools on these. Then we'll also sand out the little spots where these attach. And then we'll take the ring and the sprues and attach it to one of our rubber bases. The rubber bases match the flask, which is this cylinder in the back. It's like an empty can made out of steel. So we will, you see I have 2 different rings here that have been attached into the rubber base. Before this happens, though, we have to weigh it. I thought I had a photo of that, but we have to weigh our wax so that we know how much metal we're going to need when we cast this. The next thing we do is we invest, and this has nothing to do with putting our money in the stock market or in certificates of deposit. What this has to do with is putting a plaster-like substance called investment. Like plaster, it has a certain timed cure time, and we have to work within that time. We have to follow carefully. We have to be clean, and we have to be very aware of time while we're working on this. It's a timed process, and our investment will cure usually within 12 to 14 minutes, and we only have about 7 minutes total to work through this whole process. So we will go over this during class. I'll take you into the back and I'll show you the investment area. I will go through and invest things with you. As the as the investment cures, you see what we'll mix it up, we'll pour it in, and then this is what the top is going to look like. This is what a fully invested flask looks like. We will mark it with names, class, metal, and the weight. Here we go. We then, the 3D print tech will then take off the rubber base, or not the 3D print tech, whoever is going to start the burnout. We actually don't, we normally have a casting tech in MJCC, but this semester we do not. It is usually a grad student, but because of, the situation this semester, all the instructors and the tech have to step up and try and do that for you. So I will actually be starting the burnouts for our class. And that's why I said I'll be coming in on a Sunday night and I'll be starting the burnout. But at that time, I'll take off these rubber bases and I will load all these flasks into the kiln for Monday on Sunday evening, and I will start the kiln. The kiln goes through a process where it will stay at certain temperatures for a certain amount of time, and then it'll ramp up to a different temperature. It starts at 300 degrees, it stays there for 2 hours, and it goes up to 700 or 900. It's programmed. It's a burnout cycle is what it's called. And once I start the burnout cycle, it runs by itself until the next day. After it finishes the burnout cycle, it will hold the flasks at casting temperature. And in this case, that casting temperature is about 900 degrees. We'll come in and if needed, I will adjust the kiln to change the casting temperature if I feel that's necessary. Sometimes when pieces are really thin, we'll up the casting temperature a little bit. If we're working in bronze, we'll maybe keep it at 900, 1,000. It all depends. But generally the kiln will sit at 900 degrees until we do something with it in the morning or afternoon as it is. It'll stay like that for 8 hours after the burnout finishes. If the 8 hours passes, the kiln will then stop staying at 900 and the temperature will start to drop. So once I come in, I'll be playing with and adjusting the kiln. And we may even start casting earlier if any of you can come in sooner than 12 o'clock on that day that we're casting. We'll talk about that as time gets closer. But then, so this is what happens during the burnout process. This is a different kiln. This isn't actually our kiln. But in the process, you see the wax will melt out of here. It's the resin wax combination will melt through the bottom. And because we had this, you see this little like bump, it's called a button. And we attach our sprues to that. But when the rubber base comes off, that becomes like a little funnel. And that's going to help to direct your metal into the void that is going to be eventually turn into your ring. So we will then use our centrifugal casting machine. This is what we have in the back. By the way, this photo was taken before COVID. So we used to just stand back there, close together and huddled around, and we'd look at the casting machine, and then the lid gets pulled down and the casting happens. The centrifugal, what happens is the whole thing spins inside here. So, but now it's just, I'll be back there with you. We'll both, be masked. We'll both have eye protection and wear welding jackets to be fully protected. So we'll melt the metal in the crucible in the casting machine. I'll pull the flask out of the kiln with tongs because remember it's at 900 degrees or so. After it is spun around in here and the molten metal is melted and goes in, we'll pull it out of there. We'll set it here for a minute or two so that it'll come down to a temperature to quench it with. If we quench it right away, we run the risk of causing cracking in the metal if it cools too quickly. So we wanted to let it, quick cool so that the metal is able to, fully stabilize. And then while the flask is still hot, we'll put it into a bucket in the sink in the back area there. And then we'll start to clean away the investment. So all of this was wax or castable resin rather. To finish up the piece, we're going to need a jeweler saw. We're going to need files, perhaps some abrasive paper. We may use the scratch brush polisher. We've got some options. We could, possibly buff them. We can use different finish ideas. We can use liver of sulfur to change the color of it. But this is how we'll get the metal piece. The sprues will all still be attached, and we'll clean them up. This is why sprue placement is important. You want to put the sprues somewhere where you can cut it off and then easily finish it so that you won't see where the sprues were before. Here's that piece there as it came out of the, this is how it came out of the flask. And here it is after finishing. Okay, here are some other examples. This was from 2 semesters ago. There's another one. Okay. Here's one from last semester. It's another one from last semester. It's from a couple semesters ago, if any of you know Teddy Kaplan, the senior. Great stuff. This was from last semester. And these are all CAD 1, just so you know. So you have the potential to make things like this as well. So here's our project overview again. So we're going to use Rhino, and we're going to make a ring. We do want to measure our fingers, so we're going to need to do that when we're in class using calipers. Then we're going to prepare the 3D model. We're going to add the sprues in Rhino, and then we'll submit our file for 3D printing by the end of, I don't think that that's the correct date. I thought that I had a different date up here. Where am I at? I thought that we were gonna, no, that may be right. Wednesday, March 9th. Okay. So that's a month from today. We have a month to get these files done. All right. End of class, Wednesday, March 9th. And then between post-cure, actually between cleaning off the support structure, post-cure, and then investment, we'll need to get those invested flasks done so that we can cast for Monday, the 21st of March. I'd really like to get everybody done during the same class period. Then we'll take those metal rings and we will have a group critique on Monday, the 11th of April. Here's more of our, this one definitely. Yeah, it's not Monday, March 7th, it's March 9th. And then the post-cure investment is probably the following week. I'll edit this, I'll make sure that the syllabus is updated. Okay, that's a lot of information. Does anybody have any questions? Nope. Okay, so maybe you remember from your from when we first went over the syllabus, the materials for this are included for bronze. If you decide that you want to cast your piece in silver, then you are welcome to do that. You will have to pay for the silver. We do keep silver in the tool room for this project for just that purpose. And we have forms now that we use to connect with Brad Lunsford. He's our studio tech. Brad will set aside the metal that you need. You will get enough metal to cast the piece to include the button and the sprues and the ring. But after you finish casting, we will cut off the sprues and the button, and they will get returned to the tool room, so that all that you pay for is the metal in the ring and not the metal in the entire casting. This is actually really helpful because then that way you don't have to pay for a lot of silver that you're not going to use. That is, if you want to cast in silver. Otherwise, bronze is included. And that is included in your course fees. And so is the cost for the 3D printing, the 3D printed part that we will have. In classes after this, you'll be paying for this stuff. So, you know, it's good that you don't have to worry about that with this class. Any other question? Any questions? Nobody asked a question. Come on, guys. Maybe I should have made it more complicated. All right. Okay, so that is our project introduction. So let's take another look at some of the examples. I like showing you guys the examples. So this was not very difficult. This was actually done. It sort of looks like a sub D construction, but this was actually done before we had sub D. This was done 2 years ago, I think now. Nice, fun little one. The renderings for this piece came out really interesting because they did them a little differently and, you know, made this piece look as if it was glass. But this is a really interesting, you know, she made the fish and then used flow to just flow the fish right there, had this little, you know, kind of bridge between two rings that fit on their finger. This was just a basic sweep to or network surface command. Here you can see some of the spots where the support structure was connected and, you know, not cleaned off as possibly well. So that's one of the things that you're going to want to keep in mind. So this was kind of fun. You know, you can do stuff with this is a ring that fits, you know, it allows for space for the two fingers on either side. It's a heavy ring. We've got, you know, a name, differenced out. Here's a beehive, kind of, not beehive, but a honeycomb design. This is an example of how small holes don't always fill up or don't always stay as holes. Oftentimes in the casting process, you might have issues with things filling up. And actually, this piece was done before we started the post-cure process. We found that our success rate has gone up exponentially. Because failures like this used to happen randomly. You can see a little crack over here. We would get porosity. What was happening here actually was during the part of the process where we have the burnout and the pieces, you have your piece melting out of the inside. Okay, this is where, you know, the resin is there and it melts. Well, in the heating process, the resin actually expands a tiny bit. And if the investment is in a really intricate pattern, then the pattern can break up a little. And then you don't have as smooth of a surface anymore. One of the things that has helped that is the post-cure process where we soak the part in glycerin and then cure it some more in the UV light. And that helps to stabilize that piece more so that during the burnout, those expansions don't happen, which break up the investment. So, and that's when, you know, we can get detail like this. This piece was obviously cast in silver. This was mainly just done with some Boolean unions. Then we used the flow along surface command to move it into the ring shape. So basically, this was laid out flat in Rhino. I'm going to show you some of these commands and techniques. This piece was colored using liver of sulfur. Teddy put it in liver of sulfur and then polished the sides. So you can see it's kind of darker here. It's darker in the inside and it's dark in this area here. But this outside part and on the other side as well is shiny silver. This piece was really a amazing kind of fun thing here. And hold on, I'm going to stop sharing for a second. I'm going to also pause my recording, and I will be, let's get our recording back. I'm going to go back to sharing my screen. I do apologize for the interruption. Okay, so what is really amazing with this part, and this is where I do want to bring up the fact that this post-cure is very important to the process, is that these were very thin openings in this ring, and they go all the way around this, the front of the ring in each of these little rectangles, and they go straight through. This casting came out nearly perfect. And I do think it's important to keep in mind that we can get really creative with some of the geometry here. So with that, I'm going to stop here. And again, see if there are any questions that anyone has in mind. All right. Where are we? Where's everybody? Oh, here we go. Okay. My goodness, my little participants panel like disappeared, and I was thinking, oh no, I didn't. All right. Okay, I'm gonna pause that recording. Oh, I see something in the chat. Okay. Eiley asked if we can attach things to our rings after casting. You can. We'll have to talk about your design and why you would want to do that. You can solder it. These are, the rings will be cast in either bronze or silver, so we'll be able to, treat them as such. So if you are familiar with soldering, maybe there's a reason to do that. Let's see. Any other gem setting? No, we're not going to be doing any stone setting. Not here. That's a little advanced for CAD 1, guys. That's worth a shot, though. I understand asking. Okay. All right. Okay, I'm going to stop sharing. Let's go back to our basic Zoom. And here's my video back. All right. Okay, I'm going to pause the recording. And okay. So I want to right now show you briefly about measuring our fingers. We'll actually do this in person on Monday, but this is how we're measuring our fingers. I'm sure that all of you have gone to a jewelry store or, and use those little rings. They have them, they have a whole bunch of them and they jingle and they're very, very fun. And you try on, a different number for your finger, and it has a number on it. It may say size 6, it may say size 8, it may have a little dash, meaning 8.5. Those aren't super precise. And that 8 doesn't correspond to anything. That 6 doesn't correspond to anything in particular. So, and sometimes you can try on an 8 at one jewelry store and then try on an 8 at another jewelry store, and they won't fit the same. That's just how it goes. There's not a lot of precision across, there's just not a lot of precision across the industry around ring sizes. There has been a movement in recent years, maybe the last 10 years, of trying to standardize exactly what those, what they mean. But generally, the best way to know what size your ring is your finger is to measure it. So that's what we use calipers for. To use calipers, yeah, this is really tricky. You always shut them. You hit 0 while it's shut. This calibrates it so that you know that it is now closed. You also check the units. I have this in inches because I like to work in inches. So I'm going to open this up and I'm going to measure my pinky finger. I have to do all this in front of my face with the blurred space, right? And I'm going to move my finger in and out of it and make sure that that's where I want it. then I'm going to look at the number here, right? Yeah, the number. And it says 0.584. So that's my left pinky. Your right and left hands, once you start measuring them, you'll realize that they are different from one another. Okay, so that's 0.584. I'm going to write that down. I'm going to write down left pinky. And now I'm going to start to share my screen. Okay. Can everyone see Rhino? I hope so. Okay, great. Thank you for the thanks for the thumbs up. Okay. So as I said, my my left pinky is 0.584. We okay? Did somebody have a question? No. Okay. So I'm going to go over here to my the left hand or the right hand panel, and there's this little tab here. That is actually notes. And I'm going to make some notes because these notes will stay with this file. And I'm going to say left pinky measures 0.584 inches. And I'm going to, you know, this is the ring that the finger that I'm designing for. One thing you want to keep in mind too is that your the diameter of your ring, your fingers for rings actually changes throughout the day. On a more humid day, your fingers may swell. On a cold day, your hands may shrink or contract. So you want to try and measure your fingers a couple of times just to make sure. Let's see what else we got here. So now what I'm going to do is I'm going to create a reference for that. And I'm going to start with a circle. It's asking me for the center of the circle. It's 0, 0, 0. That's where we're going to put it. And it's asking me for diameter. So the diameter I'm going to want to put in is 0.584. Enter. All right. And that's where we're at. Let's see. We're going to go ahead and pull this on the top. And so this is now, I like to make one of my layers a reference. So I'm going to say pinky size reference is what I'm going to call that. Let's put the I in there. Pinky size reference. And I'm going to make this curve here, this circle. I'm going to move that to this object. Okay, do we have a new chat? Could we also measure our own rings that we know fit? Yes, you can. Absolutely. And that's actually not a bad way to do it, especially if you wear that ring on a regular basis. I'll show you how to measure the inside diameter. You actually use the other part of the caliper, the piece near the top. But bring it in, make sure you bring it to class, and we can measure that. But it's also important to try and measure your fingers too, and just get a feel for it. Great question though, Claire. Okay, so we have this here. That's our pinky size reference. And now once we go building our ring, we can make that we can hide that or show. But one thing I do want to do is lock. I want to lock that that layer. But before I do, I'm going to make a copy of it. I'm going to call this working ring design. This red layer. And I'm going to take this and I'm going to make a copy of that. See how it says copy objects to layer. So now there is and it doesn't look like anything happened, right? But if I lock the white layer and, you know, I can hide it. All righty. Sultan, are you having internet issues? Okay, I guess so. All right, so.
Yes, sorry.
That's all right, that's okay. This happens, just keep coming back. And let's see, Anne, you raised your hand. What do you got? Go ahead and unmute yourself and you can just yell out.
Oh, I didn't mean to, I'm sorry.
Oh, okay. All right, no worries. Okay, so here I've got my, this is what my ring size is. So there's a lot of different ways that I can start to make a ring here. One, I can do the example that I showed you in our presentation was done with like a sweep 2. And what we can do here is I'm going to make a line from the midpoint. I'm going to make sure my quad O snaps are on. Yes, they are. And I'm going to go over here to the quad, to the right-hand side there. I'm going to start my curve there. And over here in the front viewport or in the right viewport, I'm going to hold down Shift. And let's see, how big do I want so if I want my ring to be like a 1/2 inch thick, I'm going to make each end of this line 0.25. So I'm going to do that and now hold down Shift. And now this line is a 1/2 inch long. And that is actually, it could be the side of the ring. And now I'm going to take a control point curve and go like this. All right. And there. I'm going to hit enter. And right now, by the way, we have the default layer. That is our current layer. And remember, wherever the check mark is, that's where all the new geometry is going to end up on that layer. So right now, that's why all these lines that I'm drawing, these curves, are black. So I could join these two curves. Right now, they are, if I select them, you see it says 2 curves added to selection. You can see a lot of what you're doing up here in the command line. So I'm going to use the join command. And now 2 curves joined into 1 closed curve. Remember, Rhino tells you what it's doing all the time. So I've got 1 closed curve. I can use the sweep 1 command. And it says select rail. The ring here would be our rail. I'm going to hide our size reference. Then here it says select sweep shapes. We're going to do that. I'm going to hit enter. Okay, it says drag seam point to adjust, press enter when done. All right, that seam point looks fine. We only have 1. And here I'm hitting OK. Wow, that's, and we're still in wireframe here. Let's go to ghosted so we can see what that ring looks like. So we know that this is the ring size that we have. I can tell you right now that this ring is going to be too small, even if that's the finger size. When your rings start to get really thick in this direction, you need to make them a little bigger in order for them to fit on your finger and to be comfortable. This ring will feel like it's too small, even if that is the diameter of the finger that we measured, especially for a pinky ring. Pinky rings should be smaller. So I'm going to delete this. And I'm also going to delete this. But before I do, let's take a look at how thick that ring really was. Let's use the distance command, DISTANC. And we're going to go from here to here. My goodness, that's 2.299 inches. That's more than a 1/4 inch thick. That's really thick. And then to have that much width on both sides is a lot. I'm going to delete this. And I'm going to show you another way. We're going to take this curve and I'm going to drag up. I'm going to tap Alt. If you tap Alt when you're dragging, see, it even says it in the command line. You'll get a little plus sign next to your gumball. And that means that I made a duplicate. So now I have 2 curves. We can do another similar thing that we were doing with the sweep, but now we can use the sweep 2. So there's one curve there. And now we'll do this again, except this time we're going to make it a little more refined. Let's go here. Maybe we'll do this. Okay, and I like that. So I'm going to mirror it. I'm going to make a copy of it from the midpoint here to here. Those, they overlap. So I'm going to use the trim command. Remember, we just learned the trim command. I'm going to click on trim, and now I'm going to go here, and I'm going to go here. We're going to hit enter. Okay, so the trim command broke history on those two objects. I'm also going to join those two. And now if I click on this, we have all the points. I'm going to delete that one. That'll make that a little bit nicer. And now, instead of just sweeping that one around, I'm going to join this. Two curves joined. And now I'm going to mirror it. Let's try and do something a little more interesting, right? Now we're going to take the one on the other side, bring up the points on there, and I'm going to change this. Okay. And maybe go this way too as well. Oh, that totally flattened them out. Let's undo that. I didn't want to completely flatten it out. Let's go here, take these 2 points and go like that. All right, so this is 2 separate kind of profiles. And so what we could do now is we could use a command called sweep to. It's similar to the one I just showed you. And we're going to select these 2 rails, select one rail, select second rail. Remember, you know, our command line is telling us exactly what it needs. Now it says select sweep shapes. So we're going to select this guy, then we're going to select this guy. And with the sweep to command, we could have had 15 of these all the way around the edges. But what's important is that you choose them in order. I only have 2, so it's not as important, but I'm going to hit enter. Here's where one thing that is important is we want to make sure that those arrows are facing the same direction in relation to one another. Meaning that, you know, if you're sweeping around, you want both of them to face up. And I can show you what happens if we don't, but I'm not going to do that right. I'll show you that in a minute, but they're both facing the same direction. That looks great. I'm going to say press enter. And so that's what we're going to do. One thing that we are going to want to say is closed sweep. We hit OK, and here's what we have. I can make this shaded, which makes it more solid. And we can see that, you know, we have that kind of band in the middle just by having it one shape on one side and one shape on the other side. Has this band have sort of a little like an idea of movement or something. But this, so this is a nice basic ring. Let me undo that real quick, and I'll show you what happens if those arrows are facing the wrong direction. So let's go and go sweep to again. And the command is sweep to or sweep to rails. You can find it under the surface command. So select the first rail, and here's the second rail. You always need two rails to sweep on. They can be closed or they can be open, but they both have to be either closed or open. They have to be the same in terms of that, but they don't have to be the same shape. So I'm going to choose this guy, and then I'm going to choose this guy. I'm going to hit enter. And now if I click on this and make that, you see how these arrows are facing different directions? If I hit enter and tell it to do a closed sweep right here, this is really weird, right? What happens here is it got twisted on itself. And this is in shaded, but yet it's not let's see what happens if we do show edges. It should have, yeah, it's got edges, but well, anyway, we'll close that, the edge analysis. But this is not correct. This is not printable. It actually intersects on itself here. So let's undo that. Undo again, undo again, undo again. No, wait, redo. Okay, let's go back. And what we can do actually is, let's go with the, no, let's not do the array polar. Let's just make a copy of that. We're going to rotate that. We're going to make a copy of it. The center of rotation is going to be the center of that circle. And remember, with your center O snap, I'm turning it on now, you run your cursor around the outside. And when the center O snap lights up with the little CEN, that's when you can click. So that's the angle of the first reference point. I'm going to click on here. I'm going to put one up here at our quad O snap. Where's our quad at? Yeah, there we go. Whoop. We want to go this way. Yep, it says perpendicular. It'll give me the perpendicular, and then we'll put one over here too. Yeah, I got the quad there, and I'm going to hit enter. So now I have 4 of these. You can see that these 2 that I just added are showing up here. Now here I can actually create a little more variation on this. We can go really far in. Hit OK. We'll hit this here and that. We're going to move that way. And this guy, we'll do that. Go here. OK. And we're going to move that actually out a tiny bit there. So you can see that we have all these different shapes now. And I'm going to do sweep 2 again. Sweep 2. There. I'm going to hit enter. Oh, sorry. Sweep, select first rail, select second rail. And that's right. Now we just do the shapes. We don't hit enter. And remember, I have to do these in order. So I'm going to do it here. I'm going to go 1, 2, 3. Our top viewport makes it easier to keep track of the order. And you can see here that all the arrows are facing up. I'm going to hit enter again. Again, I'm going to click close sweep. And here's what our ring looks like. A little silly, not too bad. It's not that different from what we had before. We had a little more control over how the shape transitions from one to the other. But that's our ring. Now what we're going to do real quick is I'm going to show you how this ring would get sprued. Now, spruing is kind of an art in itself, and it all depends on your piece. As I said in the presentation, we do want to have, you want to try and attach your sprues to a place where you can easily clean up. One place that I can easily clean up on this ring is the inside. And that sounds a little nutty, but that's where I'm going to put the sprues on this. I'm going to use a control point curve, and I'm going to go here. Remember the elevator mode? I'm going to hold down control before I click so I can move my cursor into the middle of this ring. And you can see where my cursor is if you look in the perspective viewport and the right viewport, as well as the front and the top. So I'm going to click. I'm going to move out to the middle of the ring. And then I'm going to start to move down. You can see what it looks like there. I'm going to click there, and I'm also going to move a little more towards the middle of the ring as well. And now I'm going to also hold it on roughly the 0, and I'm going to move down again. I'm going to hit enter. And now I've built this curve. You can see that goes from the side of the ring down to the middle. I'm going to pipe that, P-I-P-E. And what this command does is it creates a pipe on a curve. So I'm going to make the diameter of this curve about 0.12. And I know how big 0.12 is because I have a set of calipers that I can look at. Plus, I know from experience that's not a bad thickness for a sprue. And the end diameter is also going to be 0.12. And there we go. So it's a little thick. Yeah. Maybe a little bit thick for this ring. Depends on the, so I'm gonna redo that. I'm gonna delete. We're gonna pipe again. Remember, if you right click, it'll bring up the last command. So I'm going to make this 0.08. Okay. And there we go. That's probably a better thickness, actually. So what I can do now is I can take this and I will use a command called array polar. And I'm going to use the center O snap again. And I'm going to use 3 of them. That's a good number. And that's, I don't like that. They're sticking out the outside. So I'm going to say escape. Let's do that again. But this time, we're going to select not just the escape. We're going to select not just the pipe, but we're going to select the curve too, so that we can rebuild each of these. Let's just take the curve and use the polar array. Wait, let's type it in and spell it correctly, Barb. Array, polar, enter. The center of the polar array is there. 3, and there's our 3 curves. And now I can take these and play a little more with them. Like I can move this one in. It's all right. Because we don't want the we don't want our sprues to hit the outside of this ring. All right, so we're going to put that there. Now we're going to pipe these. P-I-P-E. Enter. That's fine. Actually, what I should do is take the curve for that one and move it a little bit so that these don't. Now, because I have record history on, see how that pipe updates all by itself. I keep record history on so I could use it for those kinds of handy things. And before we do the other one, we're going to move that pipe a little bit too. We don't want these pipes to have the same exact geometry in the bottom here, because if that happens, the Boolean union command will not work. And we'll all find out about that in a little bit. Let's see. So we're going to go pipe, P-I-P-E, enter. And we're going to keep that at 0.08. And there we go. So we have now these 3 sprues that come out. I'm also going to put a thicker sprue. I'm going to put a poly line roughly in the middle here and put it right here. And I can see in the right and front viewports where my cursor actually is. And I'm going to hold down shift and go down about 1/4 inch, enter. And then I'm going to put a, I'm going to pipe that as well, but I'm going to make that the 0.12. Actually, let's make that 0.15. Enter, enter. There we go. So now these guys are leading into this other sprue, and this sprue can get put into the button. So what will be the last thing that we do? I would save this before I do anything else. I want you guys to get in the habit of saving. So I'm going to save this, and I'm just going to save it on my desktop. Okay, and I'm going to call this demo ring 1. Okay, and I have saved that. However, before I go any further, let's say this is my final ring. I want to make sure that I save this off to another layer. Let's call this layer render ring. And the reason we want to do that is because we're also going to be making renderings of our rings. I'm going to copy that to that layer. So if I make that the active layer and hide the default, all I have there is the ring. And this is great. So I'm going to go back to working ring design. I'm going to hide the render ring, and we can see just those 2 curves that I had. I'm going to also make another layer for the sprues. I do this when I'm casting things. I make another layer for the sprues, then I make another layer for the entire thing, and I call this unioned for print. Okay, and so the sprues, I'm going to save on my sprue. I'm going to change their layer, change object layer. That's going to be my sprues layer. And then the working ring design, which is my main guy here. Actually, let's hide those sprues right now. We're going to take everything here and put that on the working ring design. So when I show my sprues, we can see here that we have the ring and we have unioned for print. I also have another one just for rendering. I like to keep one spare somewhere. Sometimes I'll save that as a separate file, but there's the green. So we're going to keep that one hidden. We're going to keep our reference size also hidden. And in unioned for print, I am now going to take everything except curves. This here area is my, this is a selection filter. You can bring that up. I'm going to close it right now. You can bring it up by typing in selection filter. Okay. And I like to keep it docked up here so I have it all the time. Right now, what I'm going to do is I'm going to uncheck curves, which means that I cannot select curves. So by selecting here, I've gotten the solids that I need to create my union that's going to get printed. I'm now going to copy all those to this layer, unioned for print. And now I'm going to hide the ring and the sprues. Now all I have are these. And what I'm going to do now is I'm going to use the Boolean union command to check these for naked edges as I do the unioning. And then also this will be my final piece to go out to the print. But let's check all these pieces first for naked edges. So the way we do that is we go show edges. And here's our edge analysis. And right now it has non-manifold edges. I'd like to get this checked. And this is the color that'll show us if it found any naked edges. But we can also look up here in the command line and see that there are no naked edges. It already found that out for us, which is great. But we're gonna leave the edge analysis up anyway, because sometimes naked edges happen as you Boolean things together. Now, Boolean union is a really powerful command in that it can take solid, closed solid objects and specifically surfaces or polysurfaces or extrusions and union them where they intersect. We're going to take these two pieces and we're going to type in Boolean union, hit enter, and it says creating meshes. So now you can see when we click on that, those two things are the same. If we look at this in Ghosted, we can see, this is not, we'll hide these other guys, hide. You can see that that now they are joined here and there's no overlap inside. The outside surface of this has been combined from these two. Now let's show our other hidden parts. Let's now get this, and we're going to use the little icon on the side here. It says Boolean union. And again, it created those meshes. So one of the things that we want to check as we do this process is we're going to add the objects here and make sure now it has more edges, 25 edges, no naked edges, no non-manifolds. Great, that's what we want. We don't want naked edges. We're going to union this, and I'm going to, again, hit that icon. It did create the meshes, pressed escape to cancel. Now the ring is still separate, you can see. So now that's going to be the last union that we do. It's Boolean union there. It created meshes. Let's check for those edges one more time. Great, no naked edges. This here is what we could send to the 3D printer in the print lab. So how do we do that? I'm going to give you a very quick rundown here just to get you through the whole design and print process. We would select it. We would then go File, Export Selected. And now we're going to change the file type that we're exporting. We have to scroll down a bit and we have to go to this STL file, stereolithography. I'm again going to save that to my desktop and I'm going to call that demo ring 1. But this time, okay, I'm going to hit enter. It's saving it as an STL. We want to make sure that this number for tolerance is at 0.001 inches. If you work in millimeters, it has to be 0.0254. We'll remember that when we're exporting. Remind me if you work in millimeters when we're in this process. I'll hit OK. It also asks if it's OK to do it in binary, and that is fine. We're going to hit OK. And so now I'm going to close this, and we're going to go find that that demo ring here on my desktop. Except you guys probably can't see that. I just realized. All right, that's okay. We'll stop there. Any questions so far about what I've showed you? Okay. All right, well, I'm going to stop that there. And did I stop the recording? No, I haven't. I stopped the sharing. Okay, so our next thing we're going to do, I'm going to pause our recording because we're going to go into breakout rooms. Okay, where are we at here? Stop everybody. Coming back from breakouts. All right. Participants. Okay. Okay, and we should all be back together now. And I am still recording. And so I did promise those of you who had questions. And as I said, I always like to lead the link project out there as a little challenge. It's kind of a, it's a good thing to try and get your head into thinking about the more technical ways that we can use Rhino and recreating things from a schematic. So this is the link, and here are the exercises for the link. It looks like it could be a bracket for, you know, maybe some sort of a motor where you may adjust a belt or something like that. It's kind of a fun thing. But if you ended up going into product design or, you know, drafting in any way, you might get drawings like this, and they'll say, hey, here we go, create this, create it in inches, you know, make it solid, whatever. And this is the kind of instructions you might get. So I'm going to close this. Actually, I may try and see if I can make this a little bigger. All right, and now I'm going to bring up Rhino. Okay, I want a small objects inches. And actually, can you guys see my Rhino? I don't know if you can. Yes, no.
We can.
You cannot. Okay. All right. Let me fix that. I got to stop sharing, and I'm going to share again. I'm going to just share my whole screen. Thank you. I don't always know what you can see and what you can't. Okay, it says you can now see my screen. So what I'm going to do, and by the way, if you have any questions while I'm doing this, please shout out or unmute yourselves so that I can see. I usually don't, I'm not able to always see participants or the chat. So here, I'm going to take this and move it over to the side. We're going to bring this up, and I'm going to move my Rhino over to here a little bit. And we're just going to work in the top viewport anyway. And we'll move this layers over. All right, so this is what we're looking at here for this guy. And this is tricky. So, and as I said to a number of you, you can do this. You could do this exercise probably 15 different ways. It's a really, and I know I put that number out a lot, but there are so many different ways to build this. Myself, what I would do is I would start looking at the biggest number right down here, this 6. All right, I'm gonna I'm going to start with a polyline. I'm going to put it right here. I'm going to start it at the origin point, which is 0. Okay, and I'm going to use my distance constraints. Okay, 6. It's 6 inches between, and remember with a distance constraint, you know, it stops it at 6. So I'm going to hold the shift out and I'm going to put that there. Now, you may say, Barb, I don't see any 6. No, this here is 6 inches. But I could also start by putting my little circles here. So what is this little symbol here? Does anybody know that? The circle with the line through it? Do we know what that means? Anybody? That's okay. That's your diameter. All right. And if you look at it, it really is telling you what it is. It's a circle with a line through it. And that, you know, from the distance from one side to the other of a circle is the diameter. So let's pull up a circle. And I'm going to put that right here. And you can see that the center of that circle is at the end of that 6. So that's where we're going to start. I'm going to put a circle there, and I'm going to change my diameter up here in my control point in my command line to 0.63. There we go. That's fine. Now what we'll do is I'm going to copy that, COPY, and I'm going to copy that from the end here of this, and I'm going to make a copy right here. I'm going to hit enter, and that's done. So I've got these 2 circles. And the other thing that I could do is I can create another circle here with a radius of 8.1. Now, a radius is different than the diameter, right? Let's remember that. The radius is from the center of the circle to the edge. So the radius is always half of the diameter. Try to remember that. So I'm going to do another set of circles. I'm going to put that right in the center. Do I have my center O snap on? I do. So from the center to the outside, we're going to change the control here in the command line to radius. So here I can just put in 0.81. All right, that's great. And I could copy it over like I did last time, or I could just redo the command. You can see that the setting is still on 0.81. I'm just going to hit enter. And that's what I got. So now I have these outer parts. The next thing that I can do is see that this is an arc here, and the radius of that arc is 3.88 from that center, right? That's what this line here is telling me. It's also telling me that this is 15 degrees from this center line. So I can create a polyline. I like to do it this way. I'll create a polyline that starts here. And it's going to be 3.88 is my distance constraint. And then I'm going to also, so I got that. And now I want an angle constraint. And that is 15 degrees. Wait a minute, there we go. And what this does is it stops it at different angles of 15 degrees. So if I'm here and I go up to here, that's where it starts. Okay. That's good to know. I can do another one of these right here. And again, my distance, 3.88, enter. And then now my angle is, look over here, we got 30 degrees, 30, enter. So here's my 90, then there's 30 right there. So, but you know, you're going to tell me, look, these are just dotted lines. That's not part of the schematic it's asking for. No, it isn't. But right here, we can see that the diameter of this circle here, which also means this circle here, is 0.5. So let's create another circle right there. And we want that diameter, escape. Okay, there we go. We're going to put that right on the end and the diameter of that circle. So now we have to change back to diameter. One thing I do like about this exercise is it really makes you think about what you're doing with the circle command. So our diameter is going to be 0.5. I'm going to put that there. And you can see that we have the same thing over there. I'm going to copy again. We're going to go from here to here. And we're going to hit enter. Okay, that's fine. And now we're going to, we've got a radius here, and this radius of this arc goes to center. There's a couple ways we could do this. We haven't really played in the arc command much, have we? Let's go with arc. Center start angle. So here's the center, and the radius on that is 0.75. And now you can go here, and then this is another spot where it's nice to have Smart Track. Okay, the Smart Track will allow you to, oh, there we go. If you click on, if you just hover your mouse over parts of other parts of your model, it will sort of act like an O snap in that it'll tell you, hey, over here. And that's what I did. I had on Smart Track here, and then I hovered over here, and it showed there. And then when I got to here, it also highlighted, so I could stop and click there. So I've just created that part. Now, we can see that this outside, these outsides here are these circles, right? And now this radius here is a 0.75. So we're going to use one of the arc tools that allows us to create, this is cool too. You can go and hold your mouse, hover over, and you'll get tooltips. Here, arc start end, direction at start, arc start end radius. Oh, that one looks like something I need. We'll have to take a look at that. But first, I'm going to use the polyline here. I have my quad O steps on, right? Yeah, I do. So here, I'm going to go quad to here, quad to there, and enter. You see how that Smart Track's having that on? We're going to do that here too. Remember, we're going to do like trim and join at the end of all this. So we can see here that this body is done. Now, this is 0.75. So now we have to get these arcs in. And that's also center, start, and where are we at? I think that one works. We go center, start, we got that intersection there, and we've got the intersection there. So now we have that. And the diameter of this, we could use the diameter here and offset this by the diameter. Let's try that, offset. And the diameter of that is 0.5, so let's go 0.5, enter, right there, click. This is a tricky exercise. Now, if we want to do some math, we can look at this and go where we offset the difference between this diameter and this diameter, or radius, I'm sorry, radius. So we've got 0.75 and 0.5, so that's 0.25 out there. We can offset that, offset, and we'll make that 0.25. No, that isn't right. My math is not right. Hold on. Escape. It looks like it's the 0.5. Oh, right, that's the 0.25. So that's 0.5 again. Let's offset that from 0.5. 0.5, enter. And there we go. And we're going to do the same thing over here. All right, so all that we have left to do now is this arc here. And that's where we're going to use this start, end, and radius. And remember, if you're not sure about which arc is which, just hover your mouse over and it'll say. So we're going to do the start of the arc on here. And I think we need a tangent too. Yeah, we have tangent on. And radius, what's our radius here? The radius is 0.75. Oh, 0.75. Enter. And whoop, that isn't working. Wait, here we go. Wait a minute. Enter to use 0.75. Enter. There we go. All right, that is not right. I can tell it's not right. And this radius is 1.5. I'm using the wrong command, I can tell. No, that ain't working. Okay, but it is 229 and I have to let you guys go. So, all right. I'm going to stop sharing and I will get that finished for you guys. And I will have it on your demo that I'll add to the to our Zoom recording index that we have on the YouTube channel. Does anybody have any questions before I let you guys go? Nope. Yes. Okay. All right. Well, I will see you all Monday. If anybody needs anything, there are a couple of you who are going to come in early on Monday. I want to remind you about that. And if you need any help in the meantime, you know how to get a hold of me. You've got my cell and emails. All right. Have a great day.
Thank you.
Oh, you're welcome.
Bye. Thank you.
Bye-bye. Okay, since we got cut off by class, I wanted to go back in and finish this since I remembered the arc command that we needed for this last part of the these arcs here. And what we need is the one down here. It's the arc tangent radius. And it's in the lower part of the arc menu. And what you do is you get this little tangent and then you move the other tangent. And then here's where you can put in the radius. And the radius here is 1.5. And then you move your mouse to the either side of the tangents. And there's where we want that one. So now this one is 0.75. So I'm going to go back again into the arc menu. And it's right down here, arc tangent radius. There and there. And now we're going to put the radius in again. And that is 0.75. 0.75. Okay. And there we go. Now, at this point, we've got all this stuff. And we can go ahead and we can use split and join and all that to create. First of all, I know I don't need these. Delete and delete. We've got a curve here as well that we don't need. And what I'm going to do is I'm just going to use the curve Boolean command, C-U-R-V-E, curve. No, wait, not curve Boolean. We're going to use the curve Boolean command, C-U-R-V-E, B-O-O-L-E. Okay, so we're going to click inside the regions we want to keep. We want to keep this, and this. Okay, if I hit enter, I can take that one curve and these two. And this, and we can drag them away. Or undo. What we can do is we can do the curve Boolean command again, C-U-R-V-E-B, and we can tell it to delete the input all. And now we'll click inside those regions we want to keep again. Okay, and do we want to combine the regions? Yes. Output is curves, simplify curves. Yes, okay, okay. And here it is. That's all joined. These are joined. It's all good. This is the link. We're going to now extrude it to extrude planar curve straight 0.15 or 0.5 inches. There we go. And whoop, escape. We want to make this ghosted. Here we are. And that there is the link assignment. Okay. I'm going to stop recording, and this way you guys have a complete demo of that assignment.